So that's a quick example using the ggplot function, using some of the data in the ggplot package. I want to go through a slightly more involved example using a data set that comes from Johns Hopkins. So this comes from the mouse allergen and asthma cohort study, which is a study conducted here at Johns Hopkins of Baltimore children aged 5 to 17. These children all had persistent asthma with an exacerbation in the past year. And the overall goal of the study was to study the indoor environment, so the home environment of these children, and its relationship with asthma morbidity. So if you're interested in kind of seeing what a little bit of this was about, we have a recent publication, and I give the link here. So here's a little bit of the max data. You can see that there are 750 observations, and I've just put 5 variables here for the sake of demonstration. One is the ID variable. The second one is the ENO. So exhaled nitric oxide is a measurement that we take that roughly corresponds to a level of pulmonary inflammation. So a large value of ENO indicates some pulmonary inflammation. The second variable here that I want to highlight is fine particulate matter. So this is dust that is less than 2.5 microns in diameter. So it's very fine dust. And the last variable I want to point out here is these mouse positive variables. So this is a skin test that the children do, which it tells us whether they're allergic to mouse allergen or not. So here's a basic histogram of exhaled nitric oxide. So this is the log of exhaled nitric oxide, and you can see it has kind of an interesting shape. It looks like there's 2 peaks, or maybe even 3 peaks there as you go across the histogram. At the bottom of the plot here, I've got the code that makes this histogram in case you're wondering how you make it. And so I use the ggplot function to make the histogram. I've made another histogram, but I've color-coded the different groups, and the groups are determined by this mouse positive variable. So I've separated out the people who are are sensitized to mouse allergen and the people who are not sensitized. So the people you can think of the children that are sensitized to mouse allergen are more allergic, and they may be more sensitive. They have more sensitive to a variety of environmental triggers. And so you can see that roughly from the data, the blue bars are slightly higher, and the red bars tend to be slightly lower. So that suggests that the children that are mouse positive have slightly higher pulmonary inflammation on average. Another way to visualize this data is to kind of do a density smooth. So you can see that on the left-hand side, I add the geome density and to this log ENO variable. You can see that there are at least 2 peaks from the density smooth, and if you separate those peaks out on the right-hand side, notice I say color equals MoPos. So I split out the colors by whether they're positive to mouse allergen or not. And you can see that the 2 peaks roughly correspond to whether they're allergic to mouse allergen or not. And so this is a nice way to visualize this kind of one-dimensional data. Now, if you want to look at some scatter plots, I want to see whether exhaled nitric oxide is related to the level of fine particulate matter in the home. And so I'm going to look at PM2.5 and ENO. On the very leftmost side here, you can see I just make a simple scatter plot of log ENO and then log PM2.5, and it's a little difficult to see exactly what the relationship might be, but we'll kind of go piece by piece here. In the middle plot here, I've made the same scatter plot, but I've separated the 2 groups, so the mouse positive and the mouse and the non-allergic and the allergic children are separated by different shapes. So here I specify the shape argument, and I assign the shape to be this mouse positive variable. And now it's not really easy to see the 2 groups here. So there's one group that's triangles and another group that's circles, and because of the overlapping of the points, it's a little hard to see. So in the right-hand side here, instead of separating the 2 groups by shape, I separated them by color, and it's a little bit easier to see the 2 different groups in this plot now. One of the things you can do is to smooth the relationship between log PM2.5 and log ENO, and I want to look at how this relationship is different in the 2 groups. So I set the geome to be a point and a smooth, and rather than use low S, I'm just going to say I just want to use a standard linear regression model. So I say method equals LM. And that way I can look at the linear relationship between PM2.5 and ENO by whether they're allergic to mouse or not. And you can see that, roughly speaking, in the In the non-allergic children, so these amongst the red dots here, there's a little bit of a negative relationship, but it's not particularly strong if you factor in the kind of the confidence intervals there. And then within the allergic children, there appears to be an increasing relationship between PM2.5 and ENO. So another way to look at the same data is to split it out with with facets. So rather than overlapping the two groups and then color coding them separately, I can just split them out into two plots using the facets variable. So sorry, the facets argument. So here I specify the facets argument, and I say I want two columns designated by the mouse positive variable. So no and yes. So this one will be two columns, and you can see, and then I smooth the relationship within each panel. And you can see that again, the same story amongst the mouse negative children. There's a small decreasing relationship, and amongst the mouse positive children, there's a slight increasing relationship. So the qplot function is a simple function that you can use to make very quick plots, and it's analogous to the plot function. So you specify x, y, you specify your data, and then there's a variety of options that you can choose. There are a lot of nice built-in features. So if you want to color code subsets of the data, it's very easy to do. If you want to split out different panels, that's also very easy to do with the facets. You can choose different plotting symbols with the shape argument, and so it has a lot of nice things that you can do very quickly, but that are still very powerful. The syntax for the function is somewhere in between kind of the base plotting and the lattice package. I think the graphics that are produced are very nice if you like the type of design. But if you don't, there are features that you don't like, or you don't like the design of this particular function, it's a little bit tricky to kind of modify the qplot function to suit your needs. If you want to do kind of a lower level customization of different aspects of the plot, you really have to go into the kind of the guts of the ggplot function, and that's something that I'll talk about in the next lecture.